So acids and bases. Acids and bases are opposites. Kind of like positive and negative. They're opposites. In the middle, you've got neutral. Neutral's neither. It's not acid or a base. It's neither. It's neutral. So we're going to compare the acids and the bases, which are opposites, with the neutral in the middle. Acids have a high concentration of H+ ions. H+ ions are really reactive. If you go back and think about your ions, an atom that's added or lost electrons, what happened with a hydrogen atom was it had one electron. It had a choice. It could add another electron and be full like helium, but what hydrogen actually does is it gives it away. And then all it is a proton floating around. It's super reactive. It's an acid. That's why acids react with most things. Here we got HCl, that's an H+ and a Cl-. H2SO4, sulfuric acid. It's got two H+. It's very acidic. Bases are the opposite. They've got a high concentration of hydroxide ions, that's OH-. Sodium hydroxide, calcium hydroxide. Now, neutral is, it's either they've got the same or they've got both. Because water's neutral, that's H2O. That's an H and an OH stuck together. It's sort of like matter and antimatter. They're opposites. They come together, they make something neutral. We're going to carry on comparing. I'm going to compare what they taste like. Don't taste chemicals. It's a strange thing, but there are acids in your life. You drink orange juice, that's an acid. Soda is an acid. Vinegar is an acid. You eat pickles, that's acid. We use the acid in pickles to stop the bacteria eating the cucumbers. Battery acid in your car battery. Be careful if you're lifting a car battery. If it spills on you, then it's going to put a hole in your jeans and you don't want it to hurt you. If you taste any of these things, they taste sour. Sour like a lemon. A lemon's acidic. Bases, bleach, ammonia, baking soda, they're things that, they're chemicals that are often used in cleaning, because when a base reacts with a fat, it makes soap. That's why they feel kind of slippery. They change oil into soap. If you taste them, don't taste them. They're very dangerous. They're bitter, like shampoo. Shampoo's basic. If you get some shampoo in your mouth, it tastes all bitter and horrible. Water is neither. Doesn't really taste of anything. There's a useful test for acids and bases that's very simple. It's called a litmus test. A litmus test tells you, yes, it's an acid, no, it's not an acid. Yes, it's a base, no, it's not a base. And you use a piece of paper. It's a little piece of paper that changes color. And you can get two kinds. You can get red paper and you can get blue paper. Now, if you put red paper in water, which is neutral, it stays red. Blue paper, it stays blue. It's neither. If you put red paper in an acid, it stays red. If you put blue paper in an acid, it turns red. So you'd use blue paper if you wanted to test for an acid, but whichever kind you use, it's going to end up red. If you're testing for a base and you put some red paper in it, it turns blue. Blue paper in it, it turns blue. So if you're testing for a base, you use red paper. That's a litmus test. There's another way of measuring pH, which is a little more sophisticated. You can tell someone, oh, it's got a pH of 4, and they'll know that it's an acid, but not super duper acidic. It's called pH, and you calculate it by taking the negative log of the concentration of hydrogen ions. Logarithms are very clever functions in math. We're not talking about it today. Basically, you can take a curved line and turn it into a straight line. And straight lines are a lot more predictable and useful. This is a pH scale. We've got acids, pH 1. Bases, pH 14. There's no such thing as pH 15. It goes from 1 to 14, or some people would say from 0 to 14. In the middle is 7. That's neutral. Acidic, basic, neutral, neither. Opposites in the middle. And it changes color. It's red for acid, blue for base, green for neutral, and then it's sort of a gradual change through pink and orange and purple and blue and blue. I've told you already that if you mix an acid with a base, they make water. It's called neutralization. You see, they make it neutral. So here I've got some acid, HCl, hydrochloric acid, and some sodium hydroxide. Don't worry about this yet. We're going to mix these two together. So the acid is the H+. That's the important bit of the acid, remember? And the important bit of the base is the hydroxide, the OH. So we take those two, they react. HOH, H2O, they make water. Neutralized. And then you just look at what's left. Well, we've got a sodium ion on this side left over and a chloride ion on this side. They stick together and make NaCl. Sodium chloride, also known as salt. So I've got hydrochloric acid plus sodium hydroxide makes water and salt. Acid and base makes water and salt. And all acid-base reactions do that. They all make water. And whatever's left, we call a salt. So if you ever need to recognize a neutralization reaction, see if water's been made. See if there's an acid and a base.